Hey folks, welcome back to the Shrine. You know, the place where ancient artifacts of the industry just lay scattered around for us to admire. Today I'm trying to refine my 3D model and drawing a little bit. I've got this cylinder head, as you can see. And what I did is I 3D scanned the part, and based on the scan I built a 3D model, which is pretty cumbersome. It probably has 500 to 600 features, and based on that I created a drawing. So having the 3D model is one thing, but having the drawing is a completely different beast. I don't know anything about this part, but I need to adapt it to my needs, and so I need to know the exact dimensions. One of the two important dimensions are these two right here. So these angles, those are the angles for the valve. You can see the valve. This is the exhaust valve, and then this is the intake valve, and these dimensions govern the position of the valves. So the cylinder head is getting bored, and then there's a bushing that's being pressed in, which is the valve guide, and basically these dimensions will define the exact position of those valves. So these dimensions on the print are just placeholders for right now. They are approximate dimensions. So what I'm trying to do is measure that. Now the 3D scanner is going to give you a real nice point cloud data, but one of the problems with the 3D scanner, it's not going to see inside. So like there's this hole, this is the intake bore. It's going to go about 1/2 inch deep, and past that it's not going to see what's inside. So it's pretty much like you are looking at it right now, because there's not much light. You can't really see what's inside. So the way I overcame that earlier is I sectioned the cylinder head, and you can see it right here. So now you can pick up exactly the geometry of the intake channel, the exhaust channel, and maybe pick up these edges here and get the angle relative to this bottom plane. This was an older cylinder head, and the new ones I received are slightly different. So now I need to redo my previous work. So what I came up with is I went ahead and I bought a couple different sizes of these drill rods. They call it drill rods, 01 tool steel. So this is designation, that's a nominal size 0.197, which comes out at 5.0038 millimeters. And I just bought a couple different sizes to see which one's gonna fit. So you can see I can use this as a go no go gauge. So that's not going into that hole. It's not going into this hole. And I'm not pushing it hard. I don't want to screw up the bushings. So this was the 0.197. Here's another one. This is a 0.194. Okay, so that comes out at 492.76 millimeters. And you can see that this one slides in. It's got a little wiggle room. And then finally, here's a 5 millimeter rod. This was designated as 5 millimeter. I mic these, and they pretty much intolerance. But this is the one that has the best fit. So it it doesn't have barely any wiggle room, so I'm trying to move it back and forth and I cannot wiggle it. Okay, here's the same thing in the exhaust. So it just goes in and it stays put. It doesn't wiggle. So now I have this plane and I have this rod. So it would be easy to use a simple device like this protractor. Okay, it's a little rusty. I'm gonna clean it one day, I promise. So the idea is that I could set it up like so and then hope for the best and basically read the angle down here. But you can see there's several problems with this approach. The first is that this protractor leg doesn't come tangent to the rod because there's a nominal thickness for this guy and for the rod. So the other option is to use a protractor like this one. Okay, I can lay it here like so and then try to bring it close, but again it's not laying on this surface. So instead of using that protractor, what I'm gonna do is I'm gonna go and use an angle plate or a sine plate. So this is what I'm gonna do. The first thing is I'm gonna go and mount the sine plate down to the granite surface, and for that I'm just gonna use this bolt here. Okay, so once it's bolted down, what I can do is set up my indicator and just sweep the surface here. I'll bring you closer. So you can see at this edge right here, the Mihogu indicator is set to, let's say, 0. It's close. So 1 division is 10 microns or half a tau. So when I'm gonna sweep this, you can see that I have about 4 divisions, so about 1.5 tau difference in height between the two ends. Now that is just something I have to live with. I've been trying to blow it off. This is one of those tools I don't use really often, so I just blow it off, the dust, and cleaned it. I cleaned the table, cleaned it several times. That's pretty much what I have, 40 microns. So the next thing is I'm gonna take the head and I'm gonna mount the head on the top like so, and then I'm gonna incline the surface, and then the rod sticking out, I'm gonna go and indicate the rod until it's horizontal. I'll bring you back. So this is the layout. Again, the head is mounted on a sine plate. The sine plate is inclined, and there's the rod, the dowel pin or rod that goes into the socket for the valve. And what I'm doing here is I use the planar gauge to set the height, and I can adjust the planar gauge up and down. Okay, so that will set the height. You can see I'm pressing on this one here, and the planar gauge is reacting that force. So it's setting up this height from this pin to this bottom surface. And what you can see here is on this end we are running 20 minus, and then on this end we are running, let's say, 0. So 20 microns difference between the two ends. I can also try to sweep this, and you can see that there's 20 micron difference on about 3 inches length. So I think that's good enough, especially knowing that this plate has a certain amount of tolerance built into it. Now the next thing is to take the planar gauge and measure this distance, which comes out to 104 millimeters. Look at that, 2 decimal precision. 104.01. So this is what we have. The rise is 104.01. We just measured that. And then the long side is 5 inches because the spacing between the two pins on the sine plate is 5 inches, so that's 127 millimeters. So now you can see why it is called a sine plate. So if we go and divide this by that, and then we calculate the sine, that gives us that angle. So 104.01 divided by 127, that's 0.818, and then we need the sine of that. So okay, so it comes out 54.98. So we can safely assume that's 55 degrees. This was on the exhaust side, and you can see my print shows 35.4 degrees. So I need to go back and adjust it to 35. So basically I measured this angle here from this plane to there. Okay, so 90 minus 55 would be 35. So let's go and do the other side. So here's the second setup. This is the exhaust. Right now we are looking into the intake side using the same rod. It's placed, and you can see on this side the indicator is 0, and I'm going to try to sweep it, and you can see on this side it is 0 also, so it pretty much stays put. If I move it off, you can see it will go off. If I go back, you can see it will stop at 0. So this leveling is better than what we had previously. What I did is I added a little machinist jack here. So the machinist jack, I can fine tune the height, and I'm copying the height the same way. So this is the planar gauge. Just gonna slide it in there, so it's the same height. I can take out the planar gauge and go and measure the size. So you can see the size this time is 108.53. Let's do it again. 108.51. 108.52. So 108.52 divided by 127, and the arc sine of that is 58 degrees 7 minutes. And my previous size, my previous angle that I had was 30.8. So it's pretty close. I don't know why it is not an even number, but that's just what I have. I'll probably lay out a couple more heads and try to measure those and see what the average number is. I know this looks strange and suspicious, I changed the layout. So what I found out that the edge of the sine plate might not have been parallel to this machine surface, or the machine surface on the other side. So what I ended up doing is I added a fence. You can see the fence here, it's just bolted on. It's got a little spacer. And now this machined edge is parallel to the machined edge of the sine plate. So that when I angle the sine plate, I can be sure that this pin is parallel to the edge of the sine plate. So again, when I incline the sine plate, I can be sure that this pin is the plane in which the pin resides is parallel to this plane here. And so I just repeated what I did before, indicated this end. So you can see that right there, it's 10 plus, and then on this end it's 15 minus. So I was trying to be within 20 microns. This is 25 in this case. Maybe it's just me poking around with the left hand in a workshop with an indicator is not perfect. So basically this is parallel to the black top, okay, and then this little machinist jack helps me to move it up and down a little bit, and that way I can come up with the angle. So I did two measurements. On the first measurement I was mating this surface to the angle plate, and then in the second set of measurements I was mating this plate to the angle plate, and the numbers are in and they're pretty consistent. So the intake side is 58.7 degrees, and then the exhaust side is 54.92, so we can safely say this is 55 degrees. So what I'm going to do is create a test and look if I can find the angle for this plate here, which is precision ground, and so that angle should be really precise. So let's do a test. So you can see the setup. I inclined the sine plate, and right here is this precision angle plate. Okay, so I can now move my indicator along that surface. So you can see the tip of the indicator is on that surface, and when I move the indicator, it's mostly just frictional. If I move it this way, you can see it changes like 10 microns maybe. So you can see this way it doesn't change much. Again, if I move it left and right, it might change 10 microns. So now I can go and take my planar gauge, put it in there, adjust the planar gauge, and then get the size. So here's the size, 63/36. Again, I'm measuring with the planar gauge this height here, 63/36. So 63/36 is the height or the rise, and then 127. So 63/36 divided by 127 is 0.4988, and then the sine of that is 29.92. So that's a 30-degree angle. So basically this angle here is 30 degrees, and it's a precision ground plate. Here's a 3D scan of the cylinder head. As you can see, It's a sparse scan, it's a sparse representation. On this scan we mainly focused on the bottom surface and the pins. First we inserted the pin into the intake valve guide, scanned the part, and then we inserted the pin into the exhaust valve guide. Then we merged the two scans, and because of this you can see the two pins crossing. It would have been real hard to do it this way without welding the pins or pulling some other tricks. I established the plane on this bottom surface using a neat trick. You can double click on an area and then move this slider up, and you can see the software is gonna select all the points that it thinks are part of that feature. Now just simply clicking a plane is gonna establish a plane on that surface. I did the same trick with these two surfaces. You can see if I just double click on a surface, it will recognize that as a cylinder and basically add the cylinder through the surface. If I lift the slider too high, it's going to merge these two together, so that's not what we want. So this way I created the bottom plane that you can see here and these two pins. These are actual features in the file. Now I can turn off the facets, and that will allow us to turn and rotate and move it a lot easier. This is a large file, it's over 200 megabytes. So now I can select the center line of one of the cylinders and the plane, and you can see the angle shows up 58 degrees, 58.77 degrees. We actually measured 58.70 degrees with the Sine plate, so that's pretty close. Now let's measure the other one. So here's the center line, there's the plane, and the angle shows up at 55.17 degrees. We actually measured 54.92 degrees using the method with the angle plate. So you can see that the angle plate measuring method and the 3D scan are pretty close. I hope you find this video useful and learn something about the angle measurement on a Sine plate. If you like the video, please give thumbs up, and if you like the channel, please subscribe. See you next time. Bye.